Great. Question 5. This question is going to lead us, both 5 and 6, into the use of probability more towards statistics. So we collect some data. A test was given to a group of students, and we graded it and have A's, B's, and C's. We have males and females. So we've collected some data, and now we want to see how probability is related to this. So the first question is asking us, considering this data, can we, first of all, find the probability that if from this group of students we just randomly chose one student, that we would have chosen a female student. So using the data, again, it's just a ratio of looked for events divided by total possible outcomes. So the event we're looking for is getting a female, and if you look at the table, there happen to be 26 females. Then we need the total possible outcomes, and since there are a total of 65 students who took that test, our answer is going to be 26 out of 65. Now you might get frustrated, you look in the back in the book and that's not the answer, because this number can actually be reduced, a fraction. You might not spot it, I didn't myself initially, but 26 can be divided by 13. That led me to think, 65, oh yeah, 13 goes into 65 5 times. Not that I memorized it, it's just one of the benefits of being a math teacher. You start to pick up numbers. So 13 goes into 26 2 times, 13 goes into 65 5 times, and then if we turn it into a decimal, 2 divided by 5, we get 0.4. Turning that to a percentage, move the decimal over 2 places, and we have 40%. Okay. In the book, you'll see 2/5 as the answer, but 40% is a very workable answer for me, one that I can understand. The B question now is going to ask us, what's the probability that if we randomly chose someone, we get someone who did not get a C? And if you watched the video previously, for number 4, you'll see that this is there's 2 ways to kind of do this. We could look at, okay, not getting a C means you got an A or a B. Okay, but there might be others as well. So you could add the A and B together and figure out what it is. Another way to do it is to say we've got 100%, and what we're going to take from that 100% is the probability of getting a C. So we take what we don't want, subtract it from the rest, and we've got the probability of not getting that. Okay, a very powerful formula for us. So let's do it this way. How many people got a C? Well, it looks like on the table, the total that got a C was 25 out of 65 possible students. We're going to rewrite 1 in terms of this. Well, let's not do that. Because I just spotted I could reduce 25 over 65. 5 goes into both the top and the bottom. So let me do that first. 5 goes into 25. Where do I want to write that down here? 5 goes into 65 13 times. Use a calculator if you need, or up here kind of helped us. And then what I'm going to do is I'm going to rewrite 1 in terms of the denominator here as 13 over 13. Okay, so now we can take 5 minus 13. That gives us 8/13, and that's our probability. It doesn't reduce, so you'll see that is the answer in the back of the book. Again, to turn it to a decimal, which helps us turn it to a percentage, take 8 divided by 13, and you'll see you get 0.615, multiply by 100, and you get 61.5%. That's the probability of not getting